All right, good morning, everybody. Let's do this. So, here we'll do lesson 7 in the book. So we should be over here. And basically, I'll just do some of these questions with you. What it's asking you to do is, it says perform the indicated operations, write your answer in A plus BI form, and then it says do what? Identify the real part and the imaginary part of your answer. So if you want, you could do this by yourself, or if you want, you could do it with Mr. G over here. But this is something you should be able to do by yourself. So let's see. Here, I'm going to do this really fast. So let's see. 2 plus 3i plus negative 7 minus 4i. I do 2 plus 3i. This stays the same. Negative 7 minus 4i. Here, 2 minus 7 is negative 5. 3i minus 4i is negative I. And here, we need to find the real part. So here, negative 5 is the real part. And here, negative 1 is the, negative 1i is the imaginary part. Right? Here, remember, if I have some a plus bi, the a is my real part. Always this part to the left is my real, and the b is my imaginary. So this over here. Now here, let's try and do this one. I squared is what? Negative 1. So this is negative 1 times negative 4i, which just becomes 4i. But this is also 0 plus 4i. Notice that the 0 is my real part, and my imaginary part is the 4i. This is my imaginary part. Okay? Next one. Negative 3i minus negative 2 plus 5i. So this is 3i plus 2 minus 5i. And then this just becomes 2 minus 2i. Okay? And again, 2 is my real, and negative 2i is my imaginary. Okay? Next one. 3 minus 2i times negative 7 plus 4i. So here, 3 times minus 7, negative 21. 3 times 4i is 12i. Negative 2i times minus 7 is positive 14i. And negative 2i times 4i is negative 8i squared. So here, this is equal to negative 21. 12i plus 14i is 26i, and this becomes negative 8i squared is secretly just, let's see, it's negative 8 times negative 1, which is just 8. So this is plus 8. So then this becomes negative 21 plus 8 is negative 13 plus 26i. Here, negative 13 is the real part, and 26i is my imaginary part. Okie dokie. Next one. This is letter E. Let's take a look at E. Here we had negative 4 minus 5i and negative 4 plus 5i, and these will be very helpful for us very soon. So here, what is negative 4 minus 5i? What do we do? Negative 4 times negative 4 is 16. Negative 4 times this is negative 20i plus 20i, and this becomes negative 25i squared. But then this just becomes 16, negative 20 plus 20 cancel, and negative 25i squared is negative 25 times negative 1, which is just 25. So this is just 16 plus 25, and that should be 41. Okay? And notice that here, negative 4, you see these two are the same almost, but you see here there's a negative and here this is a positive. And last year we talked about a conjugate, a complex conjugate. So if you have some a plus bi, the complex conjugate is a minus bi. What you're doing is you're just, here your a's are the same. You see like here, they have the same a, my a is negative 4, this stays the same. The b's stay the same, the 5 and the 5, they stay the same, but the only thing that's different is just the plus minus. So just see another example. What's the complex conjugate of 5 plus 3i? You're just switching the sign here, that's all. Everything stays the same except for the sign in the middle. So it's 5 minus 3i. Everything stays the same, so the 6 and the 7i, and I'm just putting a plus here. What about this one? Here, don't freak out just because it's some negative radical 2 and 3. You see, these stay the same, so negative radical 2, radical 3i, they stay the same, and this just becomes minus. These are complex conjugates. And notice here, when we multiplied these together, we got a complex number. They're not conjugates of each other. Here, when we multiplied by complex conjugates, we got a whole number. We just got, oh, and Mr. G is wrong. This is incorrect. This should be 41 plus 0i. Here, we just got a real number. So the idea is, what happens when we multiply complex conjugates with each other? Like if I have a plus bi times a minus bi, what do you think will happen? A times a squared. A times minus bi is negative abi. This is positive abi. This is negative b squared I squared. Right? That's negative b squared I squared. So here, the negative abi and plus abi cancel out. So I'm left with a squared. Well, negative b squared, this becomes I squared is negative 1. So this just becomes times a negative 1. So this whole thing just becomes b squared. So this is just a squared plus b squared. And notice, you kind of did that here. Notice, in this previous problem, what is negative 4 squared? It's 16, which is this. What is negative 5, what is 5 squared? This is 25. So 16 plus 25, that's all you're doing here. Like, let's try and look at these examples. What I want you to do for this one, do the traditional FOIL. What do you get? Right? If I do 5 times 5, 25. 5 times 2i is 10i. This is negative 10i. This is negative 4i squared. Then this is 25 cancels. This becomes positive 4, which is just equal to 29, or 29 plus 0i. But notice, you could just do this formula. You're literally just doing a squared plus b squared. Here, what's my a? 5. What's my b? 2. Right? The sign doesn't matter. If you do this, what is 5 squared plus 2 squared? That's just 25 plus 4, which is 29. Or 29 plus 0i. And notice we get the same thing. Oh my god. So here, what I want you to do is get the feel for a complex conjugate for these two, and then we'll go to the next lesson. Okie dokie. See you.